Well, good morning, everybody, and thanks, of course, for the invitation to that conference as well as for the kind introduction. As you can see, the topic of my talk is non-crystalline, nanostructured solid, so-called nanoglasses. And what I want to do is to show you or try to present evidence that these nanoglasses represent a new kind of solid-state structures which seems to open the way to new, not only solids, but new properties and therefore new technological applications. And in order to do that, I will divide my talk in two sections. I'll first say briefly about a few words about the present background in terms of technology of materials, and then go on to the nanoglasses, show you what it is and why they are new and what is so specific about them and why it is so promising. So let me start with today's technology. And as you all know, in today's technology, there's a very strong preference for crystalline materials. This applies to metals, to semiconductors, and to ceramics. And the reason for that is very simple. We can change the properties of crystalline materials by introducing crystal defects or chemical defects, and in this way produce materials that are suitable for technological applications. And I'll show you two of these examples, crystal defects here. This is a high-resolution micrograph of palladium polycrystal, 3 crystals, and here grain boundaries. And you can see in these boundaries the atoms are arranged in different ways than in the crystals. And these different arrangements, by means this defect, that causes dramatic property changes. For example, the diffusivity of this palladium goes up by about 20 orders of magnitude at ambient temperatures. 20 orders of magnitude, that's about the growth rate of a tree to the speed of a car. So it's a very dramatic change. And here is a chemical defect, silver and iron. And in these interfaces, silver and iron atoms are nearest neighbors, and that also changes the properties. For example, the strength of such a material is 4 or 5 orders of magnitude higher than pure iron or pure silver. Now, such defects, chemical defects and crystalline defects, cannot be introduced in today's glasses. In today's glasses, we normally produce them by quenching the melt or the vapor, and then we get a structure which is shown for a two-dimensional case, silicon dioxide here, which is a random arrangement of silicon and oxygen, but no such things like such chemical defects or structural defects. And therefore, we cannot manipulate the properties of glasses in the same way as we can do it for crystals, and that is the main reason why glasses are far less often applied in technology in comparison to crystalline materials. On the other hand, what that teaches us is if we succeed in producing glasses where we can introduce structural defects or chemical defects, we would open the same door as we have it today for these crystalline materials. And this is what leads us then to nanoglasses, this idea